All right, eighth graders, we are doing a task called battery charging, and this is page 79 in your math binder. So at the very top here, let's read together. It says, Sam wants to take his phone and his Nintendo Switch on a road trip. An hour before they plan to leave, he realized that he forgot to charge everything last night. Who's been Sam before? Yeah, you should change that because it's very annoying when people forget to charge everything before you leave. Okay, at that point, he plugged in both devices so that they could charge as long as possible before they leave. So Sam knows that his phone has 40% of its battery life left. Yikes. And the battery charges an additional 12 percentage points every 15 minutes that it's charged or plugged in. So his Switch is newer, and Sam doesn't know how fast that one's charging, but he recorded the charge for the first 30 minutes after he plugged it in, and it's shown in the table below. So right when he plugged it in at 0 minutes, it was at 20% battery. After 10 minutes, it had raised to 32% battery. After 20 minutes, it had raised to 44%, and after 30 minutes, his Switch was at 56%. So the question that I have here for you, it's like a little puzzle that I want you to solve this problem. Which device is charging at a faster rate? So which device is charging faster, and how do you know? I want you to use your mathematics and figure out which one's going faster. Whatever method you want, show your work below, and we'll talk about it in a second. So push pause on your screen, show some work to figure out which one's charging faster. All right, so let's talk about what you did there. So one of the things that I often see students do is they try to figure out what the heck is happening here to change the battery life of his Switch down here. So how is the Switch changing? Well, I know I go from 20% of battery to 32%. That is adding 12%. And how many minutes does it take to add that 12%? Well, it takes 10 minutes. So if I look at all of these, it's always adding 12 every 10 minutes. Okay, so if I have that, that would be sort of like our rate of change there. Okay, so if I were to use my rate of change, that's an M value. And again, I'm talking about the Switch. The M value for the Switch would be 12% every 10 minutes. Okay, so what happens when I divide 12% by 10 minutes? Let's check it out. 12% by 10 minutes, and I get 1.2. So that means my Switch, or Sam's Switch, is charging 1.2% per minute. Nice. It's a pretty fast charge. Okay, so let's look at what Sam's phone is charging. Remember, it was at 40%, but it charges an additional 12% every 15 minutes. So for the phone, this rate of change would be 12%, but it takes 15 minutes. Looking at this, can you already see just by this 12%, 10 minutes, 12%, 15 minutes, can you already see which one's moving faster? They both go 12%, but the Switch does it in 10 minutes. The phone takes 15 minutes. So right now I already know the Switch is going faster. But when I divide this, let's figure out what our rate of change is. 12% divided by 15 minutes, I get 0.8% per minute. Okay, that's one way some of you might have solved it. Others of you might have solved it a different way. I'm guessing that a few of you in this class chose to use what we call equivalent ratios. Now again, as always, if you did it one way, feel free to copy down the other method just so you've got it with you. So if you did equivalent ratios, maybe you wrote down this other method just to have it. If you haven't done equivalent ratios, then you should have a pencil in your hand and you should be writing this stuff down. Okay, so let's look at what this means with equivalent ratios. I want to talk about a place where we can compare the ratio at a certain minute. So right now, I can see that we've got 15 minutes. We know every 15 minutes it goes 12%. And we also know that on the Switch, when we reached 30 minutes, it was 56%. So here's what we would do about that equivalent ratio. We would say something like for the switch, we would say it was 56% at 30 minutes. Now, the reason I chose that 30-minute place, you know that we can turn 15 minutes into 30 minutes pretty easily. I know that if I double that 15 minutes, I can make the phone also have 30 minutes on the bottom. But if I do 15 minutes twice with charging my phone, how much percentage did I get? Well, I'd have to do 12% twice. 12 and 12 makes 24%. Okay, so if I check out these equivalent ratios, which one gave me more percentage in 30 minutes? The switch, quite a bit more, in fact, like double almost. So if Sam's family leaves as planned, your job now for part B, you're going to find out what percent of the battery will be charged for each device when they leave. So remember, they were leaving, what did they say? Let's find it. They said that this was an hour before. So Sam only has 1 hour to charge his devices. Your job, what are his percentages going to be at 1 hour? Push pause and figure out part B only. Okay, let's talk about what you got. Some of you might have drawn out tables where you continued this pattern to 60, and then you might have drawn out a table for this other one and continued the pattern to 60, or just added on those 12 percentages every 15 minutes. If you did, that's awesome. Use that to help you compare with what I'm going to do next. Some of you might have started with the phone and said, for the phone, we know that there are 60 minutes to charge it. But if we remember, the phone, he only knew how much it changed every 15 minutes. So we would say, we'll take that 60 minutes and let's divide it by 15. 60 divided by 15 is 4. So there's going to be 4 of those charge bumps of 15 minutes. And every time it charges 15 minutes, you get 12% of battery. So then I can take that 4 and multiply it by those 12 percentages, and I would get 48. So is his battery at 48%? No, that's what the charge adds. Remember, the battery started at 40%. So now I've got that new 48% plus the original 40%, and that gives me 88% on the phone. 88% charged for the phone. Okay, let's do something similar for the switch. So on the switch, well, the switch was changing every 10 minutes. So the phone every 15 minutes, but the switch is going 10-minute intervals. So we are going to take the 60 minutes that he has to charge it, and we're going to divide it by how many 10s can fit inside there. And that would be 6. Okay, so there are going to be 6 swoops for charging his switch, which means there are also going to be 6 of these swoops that have 12 percentage points. So I can now take those 6 swoops times the 12 percentage points, and 6 times 12 is 72. But remember, he doesn't have 72% only. That's how much gets added on. So then I can do the 72 plus the original charge on the switch, which was 20%. And when I add that up, I get 92%. That's where the switch is going to be. Those aren't bad, but if you're like me, you definitely feel a lot of pressure anytime your phone is below like 100% essentially. Or maybe that's just me. I don't know. Don't tell me. Okay, so I feel like there are also some of you who might have chosen to use what we learned in the stuff for our last test, writing an equation. You've got the initial value for each of them. That's where they start. You've got the rate of change for each of them. So you can write equations, right? Okay, so let's start with the phone. Okay, so for the phone, my equation is y equals, and my slope for the phone was 0.8 x plus the starting point for the phone, which was, is that up here? Yes, the starting point was 40%. So plus 40. So what can we do with that now? Well, I can say y equals 0.8, and now I want to input the 60 minutes of charging. And we're still adding 40. So 0.8 times 60 minutes plus 40 gives me 88%. Okay, for the switch, on the switch, I'll start with my y equals, but now I've got to find the rate of change for the switch. Well, that was 1.2% every minute. So I've got 1.2x plus the initial value for the switch, which was 20%. Then I'm going to use my input of 60 minutes, which we learned how to do on our last test. And I'm going to add on 20. Okay, so 1.2 times 60 plus 20 gives me 92%. Okay, so if you haven't had them already, I want you to push pause and get this equation stuff on here because that's super important. It's a great connection from our last test. So I want to show you how that gets useful now. How much time would Sam need to charge the batteries to 100% on both devices? So we kept putting time in the input. Time was our X value. But here we want to know how much time. That means we want to know the input. We don't know X. So I'm going to issue you a challenge. Here's my challenge for you. On this challenge, I want to ask you, can you solve this using the y equals mx plus b equations? I want you to figure out how long Sam needs for that 100% using the equations we talked about. Push pause, see if you can get it. All right, my lovely 8th graders, let's see how you did. We are going to start with the phone. Okay, so on the phone, we had our equation, y equals 0.8x plus 40. But remember, we want to be at 100% for the output for our battery. So I am going to put 100 equals 0.8x plus 40. Okay, how do I solve this? Subtract 40, subtract 40. 100 minus 40 is 60 equals 0.8x. Divide by 0.8, divide by 0.8, and when I do 60 divided by 0.8, I get 75. So 75 equals x. Remember what we were trying to figure out. We were trying to figure out the number of minutes to get to 100%. So that means for the phone, how long will it take? 75 minutes. Okay, so our phone is 75 minutes. Yay! Let's figure out for the switch. For the switch, remember our switch equation was y equals 1.2x plus 20. Well, I want my output to be 100% on my battery. So 100 equals 1.2x plus 20. I can subtract 20 from both sides. 100 minus 20 is 80 equals 1.2x. Divide by 1.2, divide by 1.2, and 80 divided by 1.2 is 66.6 repeating. 66.6 repeating equals x. So that is the number of minutes that it takes to fully charge the Switch. So, with this information, if you were Sam, what would you say to mom and dad who said we are leaving in 1 hour? What does Sam need? If he wants them both at 100%, well, the Switch is going to take 66.6 repeating minutes extra. How long is the phone going to take more than that 1 hour? 75 minutes is only 15 minutes past an hour. So if I were Sam, what might I ask mom and dad? What do you think? Yeah, I would say, can we leave 15 minutes later? Awesome. That's the question that Sam would ask. All right, my lovely 8th graders, good luck on today's homework.